This video continues with the previous slideshow presentation of energy and work. In this video we'll be talking about the concept of power. So power is the rate of doing work. When we talk about rate, it is related to time. When work is done on a body, energy is actually transferred to it. And by the law of conservation of energy, the work done is equal to the energy transferred. So we can say that power is equal to the change in energy over the change in time. And we can see this by the equation on our screen. With this equation we can also work out the units of power. We can see energy is measured in joules, time is measured in seconds, so power is joules per second. However, the international standard unit for power is actually watts. This is spelled W-A-T-T. You might have heard items such as light globes, for example, measured in watts. So what this means is a 60 watt light globe uses 60 joules of energy every second. Let's just have a look at one example problem to enhance our understanding. We have a 75 watt light globe that burns for 8 hours. How much energy has it used? So first we write down what we know in the question. So we know the power is 75 watts. The time is 8 hours, and we have to convert that to seconds. You can see on the screen the conversion. Now we use our power formula. However, we want to know the energy, so we rearrange our equation to get this equation here. Then we substitute the values that we know. We end up that our energy is 2.16 megajoules for a light globe that burns for 8 hours. Let's just have a look at one more example. A crane can lift a 2-ton steel beam to a height of 30 meters in 8 seconds. What is the power of the crane? So first we write down what we know from the question. So the mass is 2,000 kilograms. The time is 8 seconds. The initial velocity, being at rest, is 0, and the height is 30 meters. Firstly, we determine the change in gravitational potential energy of the beam. In this case, we use the potential energy being mgh with this formula. Now that we've found the potential energy, we can use our power equation to work out the power. Now, having a look at this power equation, we see that with lifting the beam in 8 seconds, we get the power of the crane being 73.5 kilowatts. Now, if we lifted the beam in 16 seconds, so we doubled the time it took to lift the beam, our power will be half this value. If the crane took a lot longer to lift the beam, you would say it is less powerful. There are also a couple of more examples on the slides that I'd like you to have a look at so you can enhance your understanding. Now, energy problems involving electricity involve a different approach. On your electricity bill, for example, you might notice that the company charges you in kilowatt hours. This is because of the following. So if we have a look at our power equation, we rearrange in terms of energy. Now we've got our power times our time results in the amount of energy that we use. Now if we don't use our standards, international standards, we've got instead of watts for power, we've got kilowatts, and time being hours. So this is what our energy company uses, is kilowatt hours. 1 kilowatt hour of electricity is actually the energy used by running a device with a power of 1 kilowatt for 1 hour. Let's have a look at an example using electricity. If electricity was charged at a rate of 17.3 cents per kilowatt hour, determine the cost of running a light globe for 8 hours. So the power is 75 watts, being 0.075 kilowatts, and the time is 8 hours. Notice that we're not using the normal standard for power and time, being watts and seconds. In the electricity problems, we want kilowatt hours in particular, so we have to convert our values into this form. Let's work out how much energy the light globe requires. So in this case we've got power times time, and we get 0.6 kilowatt hours. Now if we remember to a previous problem, we get about 2.16 megajoules, and this equates to the same as 0.6 kilowatt hours. Now finishing off the problem, with 1 kilowatt hour being 17.3 cents, we get our final value of 10.5 cents to run a 75 watt light globe for 8 hours.